One of the roles that you may be required to perform is the testing of an area to ensure that it is safe to carry out hot work. All hot work involves potential sources of ignition. Before any hot work can start, it is vital that the AGT tests the worksite and surrounding area to ensure that there are no flammable gases present which could cause a fire or explosion. The gas detector should be checked, and you should ensure that the battery is fully charged and that you've checked the integrity of both the probe and hose. You may not be required to carry out this work under the control of work system, but it is essential that you carry out a risk assessment of what you are about to do and ensure that you're wearing the correct PPE for the work. Although you are testing an area which has not been noted as having any flammable gas, you must consider risks such as the accidental exposure to H2S. It is important that you plan the task before you arrive at the worksite. Once at the worksite, you should examine the area for any flammable gas that may be leaking from flanges, modulated valves, screwed fittings, vents and drains. You should also be prepared to assist the elected fire watcher in positioning the Sentinel-type gas detector to provide continuous monitoring once the hot work starts. The fire watcher should also be able to communicate with the CCR if an emergency should arise. All results of the gas testing should be recorded in your company's control of work system. Let's try an exercise on the checks that should be made prior to carrying out hot work. Select the 4 actions that should be taken before performing a gas test in an area to ensure that it is safe to carry out hot work. When you're happy with your answers, select the Submit button. Sorry, that's incorrect. The correct answers are being shown for you now.
On June 5, 2006, 3 maintenance workers were killed and a 4th was seriously injured in a violent explosion during a welding operation at a rural oil production field in Raleigh, Mississippi. The field was operated by Partridge Raleigh, a company that specializes in recovering oil from older, dormant wells. All the victims worked for Stringer's Oilfield Services, an independent contractor hired by Partridge Raleigh to install tanks and piping at the site. The CSB investigated and issued a case study calling for safer work practices in the oil and gas production sector, which has experienced a number of serious accidents.
Our case study noted that the fatality rate within the oil and gas extraction sector was more than 8 times higher than the average of all industries in the United States.
Well, we've been very concerned about safety in the oil fields for many years. In fact, this is the 4th case in which there have been multiple fatalities that the CSB has investigated.
CSB lead investigator Johnny Banks says there are key lessons from the Partridge Raleigh investigation that apply to many industries, particularly concerning what is called hot work, such as welding, cutting, and grinding that can cause ignition.
Workers should use extreme caution when performing hot work on any tank or container that holds or has held flammable materials. Their lives may depend on it.
The following animation shows how unsafe work practices and a lack of training led to a tragic loss of life at the Partridge Raleigh oil field. The oil field had 4 tanks. 1 was for wastewater, 2 were storage tanks that held oil prior to sale, and a 4th larger tank, a so-called production tank, received oil from the well. A Stringer's Oilfield Services crew arrived and began work to connect a pipe between the large production tank and the nearest storage tank. To prepare for welding, contract workers removed the hatch from the large production tank to clean and air it out. They then checked for remaining flammable hydrocarbons in the tank by using an unsafe and unreliable technique, inserting a lit oxyacetylene torch to check for a flash from ignition. The big tank was in fact empty, but crude oil remained inside one of the storage tanks, warming under the morning sun. Unseen by the workers, flammable vapor from the crude oil was flowing from that tank into the other storage tank through an overflow line. and then out into the atmosphere through an uncapped 3-inch pipe. This open pipe end was just 4 feet away from where they planned to weld. In order to provide a platform for the welder, a ladder was placed horizontally between the two tanks. To stabilize the ladder, 2 workers stood on top of one end. A foreman observed the work from atop the production tank. The welder, who was perched on the ladder but wore a safety harness secured to the tank, began by making 2 small welds to a pipe fitting. Sparks showered from the welding process, igniting the flammable vapor that was escaping from the open pipe end. Flames flashed back through the open pipe into the storage tank, causing an explosion which blew off the tank lid and the ladder that 3 of the workers were standing on. Flames shot through the overflow pipe into the next tank, causing an even more violent explosion from the flammable hydrocarbons inside and blowing its lid off as well. The first tank lid flew a distance of 50 feet. The other traveled 750 feet through the air.
2 workers that were standing atop tank number 3 and 1 that was standing atop tank number 4 were blown off by the force of the explosion. They suffered fatal injuries as a result.
Only the welder, who had been wearing a safety harness, survived, but he suffered a broken hip and ankle. The CSB investigation identified several unsafe work practices that contributed to the likelihood or severity of this accident. Prior to welding, workers only tested for the presence of hydrocarbons by inserting a lit acetylene torch into the production tank.
Not only is this dangerous, but it's not a good way to check for flammable vapors.
The workers did not use a flammable gas detector to test for vapor, which could have warned them that dangerous vapor was flowing out of the open pipe near where they planned to perform welding. Another unsafe practice was not capping the open pipe, especially important since all the tanks were interconnected, and one contained a significant amount of crude oil.
This case is a reminder that we need to look at hazards in the area around where we're working, that equipment that may be nearby that isn't directly involved in the job that you're doing, such as welding, can have deadly consequences if you don't address the hazards.
The CSB report also noted that the use of a makeshift work platform, the ladder braced by workers standing on top of the storage tank, unnecessarily put these 2 men in harm's way. They died when they fell from the exploding tank. The American Petroleum Institute, the National Fire Protection Association, and other organizations provide guidelines for safely performing hot work. Safe practices include issuing written hot work permits, ensuring work is performed only by trained personnel who understand the hazards, isolating areas where hot work will be performed from piping or tanks that contain flammable or combustible liquids by installing caps, blinds, or other physical devices, and using a gas detector to test for a flammable atmosphere before and during work.
Oilfield work can be extremely hazardous, and that's why training and procedures to do jobs such as hot work and welding are absolutely essential to avoid tragedies like the one in Mississippi.
The CSB found that neither Partridge Raleigh nor its contractor, Stringer's Oilfield Services, followed OSHA requirements for burning and welding operations. The accident could have been prevented if these OSHA regulations had been followed. Although OSHA implemented a special emphasis program to inspect oil fields in several other key states, in the 5 years preceding the Partridge Raleigh accident, OSHA did not conduct any planned inspections of the more than 1,000 oil fields in Mississippi.
Based on the findings of the investigation, the CSB issued several recommendations.
In addition to specific recommendations to Partridge Raleigh and Stringers, the CSB recommended OSHA's area office in Mississippi implement a local emphasis program to inspect oil and gas production companies. And the CSB recommended that the Mississippi State Oil and Gas Board, a regulatory agency, establish a program to identify and report unsafe oil field conditions to OSHA.
Accidents like this need not take place if companies follow regulations and safe work practices.
For more information on the Partridge Raleigh accident, please visit our website at csb.gov.
What is wrong with the technique being used here? Type in your answer and then select Submit. Let's take a look to see if you were right. Select the next button to move on. The test being carried out here is being taken too quickly. The sample taken must have time to be pumped into the gas detector for analysis, and the probe must remain in place for several seconds before moving on. At each test point, the AGT should ensure that they can clearly see the gas detector display screen, showing the test results. You can see the AGT arriving on site. What should they do next? Type in your answer and then select Submit. It is important to determine the physical boundaries of the area that you are testing. A large radius around the hot work area must be established, and the gas detectors situated around the boundary to ensure that adequate warning is given if the gas detectors sound. If the area is too tight and the gas monitors are situated too close to the hot work, a gas cloud could move into the area and remain undetected until it is too late to evacuate safely. It is important that you ensure that you have an adequate spark containment habitat or screen in place before beginning work. Hot work can generate sparks from grinding and molten metal particles during oxy-fuel cutting or welding, and without adequate spark containment habitats or screens, these may be blown into areas adjacent to the hot work site. After the initial gas test, you will be required to record the results either on a separate gas test record sheet or within the control of work system. Further gas tests will be required whenever personnel have left the site for meal breaks, etc., and prior to the hot work recommencing. Further gas testing will also be required at the beginning of each shift when revalidating the permit to work. It is important to remember that all aspects of the work carried out by the AGT may at times require the support and assistance of others. Shift supervisors and process operators on site will have an in-depth knowledge of the plant and equipment that you are being asked to test, as well as the inventories within pipework and vessels. Remember, experienced personnel are a valuable asset. As the AGT, you should consult them prior to planning and risk assessing any gas testing operations.